First, I'd like to talk about the idea, the theory behind what's happening as we find the length of any graph. So imagine we've got a graph that looks roughly something like this, and it runs from the x value of a to the x value of b. And we'd like to find the length of this. So one way to approximate it would be in terms of line segments. And so we could approximate it by, say, this segment, and then from here to there, that segment, and then from here to there, that segment. And hopefully you can see that obviously, although this would be an approximation, it would not be very good, particularly because of what's happening over here. So if we consider the same curve, we saw that if we broke that up into 3 subintervals, it was okay but not great, and we could see the issues. So if we do the same thing but look at more segments, so maybe from here to there, then from here to there, and then from here to there, here to there, here to there, we can see that the lengths of these segments, and there are 5 of them, I'm not sure if you can see that, this would be a better approximation than our previous one, because by increasing the number of segments, we're much closer to the curve. So then the principle is, as the length of each segment goes to 0, then we also have an infinite number of segments. And that as the length of the segment gets closer and closer to 0, and our number of segments increases, we approach the actual length of the curve. Right? Or in terms of summation, what we're doing is we're adding up the lengths of segments. There'll be an infinite number of these segments once the segments themselves have a length of 0. Right? Each individual segment gets smaller as you increase the number. And it can be shown that, so let's go back to the original graph. We'll just redraw it here. Let's say we wanted to focus in on maybe this particular segment here. Well, this segment is part of a triangle where this portion of the triangle is the change in x. This portion of the triangle is the change in y. And so by the Pythagorean theorem then, the length of this particular segment must be the square root of the change in x squared plus the change in y squared. And your book does the textbooks do a nice job of showing this. It can be shown that this is equal to the square root of 1 plus the value of the derivative of the function squared times the change in x. And so if you'll just accept this transformation or just research it a little bit more, this becomes the basis for our integral. That given some function f of x, its length on a closed interval must be equal to the integral from a to b of the square root of 1 plus the derivative of x squared dx. That this integral represents that summation process of taking the lengths of segments, getting an infinite number of them, and the length of the length of each segment is smaller and smaller. The change in x gets closer and closer to 0. So this is the formula for the length of a segment. And it can also be shown or be written in this way: the integral from a to b of the square root of 1 plus dy dx squared dx. So these are the formula for the arc length of a curve.